Today we're going to take a look at the law of sines. We've been working with sine, cosine, and tangent, but today we're just going to look at sines. So what the law of sines is, sine, cosine, and tangent we've been using to figure out missing sides and angles of right triangles. But the law of sines works with any triangle. So if I draw a triangle here, I'm going to label it angle A, angle B, and angle C. Now I'm also going to label side A, side B, and side C. So I use lowercase a, b, and c for the sides and the uppercase for the angles there. I did this for a reason. And you also notice their position is there for a reason. Angle A, opposite is side A. Angle B, opposite is side B. And angle C, opposite is side C. So this is what the law of sines says. It says that the sine of angle A divided by side A is equal to or proportional to the sine of angle B divided by side B, which is equal to the sine of C over side C. This might look a little bit confusing, but it's a pretty easy concept. Basically, if we take the side of an angle, say angle A, and divide it by the side opposite, it'll equal the sine of any other angle divided by the side opposite. So in this case, sine A over side A will equal to sine C over side C, or sine B over side B. So let's take a look at this a little bit. So here's a problem that you might see that you have to solve. So we have an angle, we have two sides, and we have this unknown angle x here. We can see that this is not a right triangle. So we can use the law of sines here to help solve this. We can say that the sine of the angle, sine of 125 over the side opposite it, so over 10, is equal to the sine of any other angle in the triangle, so in this case sine x, divided by the side opposite of it, 6. So we have an equation. The sine of 125 degrees over 10 is equal to the sine of our unknown here, x, over 6. So the sine of any angle divided by the side opposite to it is equal to any other angle in the triangle divided by the side opposite to it. So now, after we have our equation, we have to solve for our variable, which is right here. So that means we need to get rid of two things. We need to get rid of this 6, and we need to get rid of the sine right here that is next to the x. So the first thing we're going to get rid of is the 6. The 6 is dividing, right? So we need to do the opposite of that. And we're going to multiply by 6. So times 6 times 6, and that 6 over 6 cancels out, and we get 6 times the sine of 125 divided by 10 is equal to the sine of x. These problems look a little more complicated and they take some more time to put in our calculators. So we still need to get rid of one more thing. We need to get rid of the sign right here that is next to our x. So hopefully you remember the opposite sign is the arc sign. So we can take the arc sign of both sides. I'll write this in red here. So I'm going to take the arc sign, sine -1 of this side, and the arc sign of the left side. We know the arc signs and sines cancel out. So I'm left with x over here, but we have a really big mess of stuff on the left side. We have the sine of -1, the arc sine, of 6 times the sine of 125 all over 10. Looks really complicated. We can put it in our calculator just like that though and get our answer. So let's bring out the calculator. And we have here, we're starting on the left side there, the arc sine. So we find it in our trig, arc sine of 6. So I'm going to write this as a fraction. This calculator's, the fraction key is Control Divide. So if I hit Control Divide, I have a fraction. 6 times the sine of 125 on top. Oh, I didn't get my 6 in there. 6 all over 10. And hit enter. It gives us this simplified version of that, which you guys will learn your junior year. But we just want a real answer. We want a decimal answer. So we get 29.44. So x is equal to 29.44. X in this case is our missing angle. If we look at that, we know it's an acute angle. We can't really judge it by its picture. The picture might not be that accurate. But if this is 125 degrees, then that's going to have to be an acute angle, so that's a reasonable answer in this case. Alright, let's look at one more problem. So here it says find all missing sides and angles. Alright, all missing sides and angles. So we're given 2 angles and 1 side. So we have to find all the missing sides and all the missing angles. We can tell that this is not a right triangle, so we can't use the Pythagorean theorem, we can't use our regular trigonometry, but we can use our law of sines on this. Before we do that though, hopefully remember that all 3 angles in a triangle add up to 180. So we can find our missing angle there of our triangle with that knowledge. So we can take 180 minus 46 minus 28, and that'll be our missing angle there, 106. Alright, so that is 106. So now we're just missing 2 sides. Call this x and call this y. Alright, so we can use our law of sines to solve this. One thing we can do, we say that the sine of the angle, so if we want to find this x right here, the sine of the angle 28 divided by the side opposite of it, divided by x, would be equal to the sine of 46 divided by y. That'd be a true statement. The sine of the angle divided by its opposite side is equal to the side of an angle divided by its opposite side. There's a problem with this though. Hopefully you guys see it. We have an x and we have a y here. We can't solve for 2 variables at the same time. This equation isn't going to work for us. What we're going to have to do is use this side and this angle in our equation, because we know both of them. So let's erase this part of my equation. And we can write over again using this angle and this side. So the sine of 106 over 12. Alright, so we have two fractions that equal each other. The way that we solved similar triangles in the chapter before this, when we had two fractions that equaled each other, is by cross multiplication. It's another way we can use to solve this. So if I cross multiply, I get x times the sine of 106 is equal to 12 times the sine of 28. That's perfectly allowed. We can cross multiply when we have two fractions that equal each other. So that simplifies things a little bit. Now we don't need fractions. We got rid of those, which is a plus. So now to solve for our variable, we just have to get rid of one thing. We have to get rid of this sine of 106. Since it's multiplying by the x, we can divide by the sine of 106 on both sides. And that cancels out on the left side. Sine of 106 over the sine of 106 equals 1. 1 times x is just x. So we have x is equal to this big mess here on the right. Our calculator will luckily solve that for us, though. Let's make a fraction with our calculator. And then at the top we can put 12. Oh, something better happened here. Up top we can put 12 times the sine of 28. On bottom we can put in the sine of 106. So that looks just like what we have here in our problem. Hit enter, does this simplification thing for us. I want to hit control enter to get our answer, and it says 5.86. Alright, so 5.86 is equal to x. Alright, so to solve for our last side, we can do the same thing. Here's my x. So to solve for my y, we can go ahead and use the sine of 106 over 12 again, but make it equal to the side with y on it. So the sine of 46 over y. So the sine of this angle over 12 is equal to the sine of this angle over our y. If we cross multiply again, we get y times the sine of 106 equals 12 times the sine of 46. Once again, we have to divide by the sine of 106 to get our answer. And if we put this here in the right into our calculator, we should get our answer. Alright, on my calculator screen here, I went ahead and plugged it in, 12 times the sine of 46 over the sine of 106, and it gave me y is equal to 8.98. 8.98 is equal to y. So now I've found all my missing sides, all my missing angles for this problem. One easy check you can do is the smallest angle should be opposite the smallest side. So the smallest angle here is 28, and the side opposite that is 5.86, which is the smallest side. The next smallest angle, 46, should be opposite the next smallest side, 8.98. And ultimately, the largest angle and the largest side should be opposites. Hope you enjoyed this lesson. Until next time.